Hello students, today's agenda is to check homework. We'll be graphing circles and you will be able to work on 11.1. Today students will be able to graph circles and understand where the formula of the circle comes from. So let's begin by deriving the formula of the circle, understanding where it comes from. So for every circle, you will always have a center, and that center is the same distance to any given point on the circle. Okay, so if you go around and draw the radius, it's going to be the same distance to any point. So let us just draw from here to there. And so we're going to call the center HK. And from there, we're going to draw a triangle that that has a right angle using the 2 points, the point on the circle and that center. Okay, again, this point can be any point. We're just going to label it as X, Y, X, Y. And this is going to be a right triangle. And before we continue with this, for those that need to see it the more concrete, I'm going to try to explain this point right here. Okay, the distance, well, this point and the distance of this, so that we can use the a squared plus b squared equals c squared. But how does this point relate to my two given points right here? And so let's look at this that is a little bit more concrete. This point right here is going to be, for the coordinate is 4, 3. So I'm going to write here 4, 3. It's just like my HK in here, HK. And for this other point is at 9, 7. So let's put there 9, 7. And so this point right here, how does it relate to those 2 points? Well, we can say that for the X, I have to travel the same amount of space that I did for this one in X. So my X is going to be 9, and my Y will be 1, 2, 3. So now I want you to check and see what we can do. How can I find this distance right here? And I might have to move that point right there, but to find this distance, that's the change on Y. How many spaces I went on Y. And I can count the squares, 1, 2, 3, 4, but I can also subtract the Y values because again, this is the change on Y, which is 7 minus 3, or 7 minus 3, right? Is the values on the Y. So 7 minus 3 will give you 4. Again, we can count them in here, but if we didn't have those spaces or those squares, we would not be able to do that. So that's the distance in here by subtracting the 7 minus 3, which would be the same thing as 7 minus 3, because this point will always have the same for Y. Okay, what about this distance? Well, the distance I can just count again, 1, 2, 3, 4, 5. But we know, right? We know that it's 5. Let's put that there. That distance is 5. But we can also find it by subtracting X. Again, why? Because is the change on X from this point to this point, there is a change on X. And what's the change? 1, 2, 3, 4, 5. But we can also use the X values. 9 minus 4 will give you that 5. So again, it's like subtracting this 9 because it's the same here. 9 minus 4 from this line, okay, from these 2 points. Again, it's because this relationship is the same for the X value. So again, here is going to be the change or subtraction of X. And for this one is the subtraction of the Y. If we didn't have this point, for this one, it would be just like 7 minus 3 directly from here, but you sub because of the relationship, right? The relationship or same distance that they have compared to the points that they're giving us already. Again, this point right here, I'm just going to write it far away. It's 9, 3. So basically it's the 9 from here, the 3 from here, and for this distance, all I did was subtract 7 minus the 3, meaning subtracting the y's. But this 3 is the same here and here, so 7 minus 3 from here will be the same thing. And the distance here, I found it by subtracting the x with the x from this point, right? The x minus x, 9 minus 4. But again, this is the same as this one, 9 minus 4, which is the 5 right here. And what that means is that even if I didn't have this, I could just say, oh, for this, that's the change on y, subtract 7 minus 3. For this one, oh, that's the change on x, subtract the x values, 9 minus 4. Hopefully that makes sense, because now we're going to go to the abstract without being able to count the squares. And so having that means that I can just say, oh, this distance, I can just subtract the y values, meaning that from here to here, the measurement will be y minus k, okay? Y minus k, because I'm just subtracting the y value because it's the change on y. And that's equal to that. For the distance here, that's going to be, again, I'm just subtracting the x values because it's the change on x. So it's x minus h. Because this is a triangle, we can say that to find, this is the radius, right? This is our radius for the circle. And so now we can apply the Pythagorean theorem, which says a squared plus b squared equals c squared. And a and b are our two legs. And c will always be the hypotenuse, which is right now our radius. So we're going to substitute. A will be the change on x, which is x minus h squared because of the Pythagorean theorem, plus b will be y minus k squared because of the Pythagorean theorem, and that's going to be equals to c squared, which is our radius. So it's going to be our radius but squared. Okay, and as you can see, that's how we relate the Pythagorean theorem to our circle formula in standard form. One thing that I want you to notice before we go on to graphing is that in here, the point is positive h, positive k. But in our formula, it's negative h. And for y, it's also negative. So our center, when we're looking for our center, it will be always the opposite of what we have in there. So if it's negative h, then it's going to be positive h for the center. If it's negative k, then it's going to be positive k. And the radius in our formula, it's squared. But to find it, we need only the radius, not the radius squared. So we're going to have to take the square root of that. Okay, we'll see how it looks once we start with specific examples. Okay, now that we know where the formula for a circle comes from, let's use it so that we can figure out how to graph if we're given or a circle equation. So in here we have x squared plus y squared equals 9. Because we don't have any being subtracted, the center, when you just have x squared plus y squared, the center for this circle will be at 0, 0, meaning the origin. You're not subtracting, you're not adding anything to x or to y, then it's 0, 0. For the radius, and I'm just going to put r, what you have to do is to take the square root of that answer and the square root of 9 is 3, so that's going to be your radius. And again, that's because this is the radius, and here in the formula is the radius squared, so you have to take the square root to find what the radius is. Okay, so in here the center is at 0, 0. Then the radius is 3 spaces, so you can just count 1, 2, 3. You can count it once and that's it. Or if you want, you can do several just to make sure. You can go to the right, to up, to the left, down to make it more accurate. And again, it all depends on what kind of tools you have. We'll try our best, especially that these are very tiny squares. And what I recommend is that you turn the paper instead of turning your compass, unless you're very skilled with your compass, then that's fine. And there it is. This goes a little to the left. Let me do a close-up. So there it is. Okay, we'll do our best with the tools we have. Number 2. Now they decided to put the radius on the left. It's going to be the same thing. You're going to take the square root of that answer to find the radius. And the square root of 4 is 2. For the center, remember that for x is the opposite of what you have in here. It's negative h. So if it's negative, negative 3, will be positive 3. In here is positive 2, is the opposite of that, so it's negative 2. Okay, always change the sign for x and for y. Now we count 1, 2, 3, and then negative 1, negative 2 is right here. That's my center. The radius is 2, so 1, 2, 2 up, 2 to the left, and 2 down, and then you will find it easier. Okay, and now we graph. So again, it's easier to just turn the paper around, and not so perfect. Oh my, I made a big hole in there. Okay, more or less. Hopefully I didn't get you dizzy. Again, do your best, but you can see, and that's making a big hole in my center. But that's okay. Let's keep going. So in here, for our center, it's the opposite of this, which is positive 1, so it will be negative 1 for x. For y, it's negative 4, so it's going to be positive 4. And for the radius, we just take the square root of the answer, and that gives us the square root of 121 is 11. So the center is at negative 1, positive 4, negative 1, 1, 2, 3, 4, right there. And the radius is 11 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. And I'm not going to count up or to the left because I don't have enough spaces, but now let's graph. If you want to do only one point on the circle, what you can do is just put a different color for the center so that you know where to put your point, and the other one would be your, would be your pencil. Okay. See, it's easier to just turn the page. See? Not my fault. I'm just kidding. Yes, take the time to erase it, please. There you go. So that will be my circle for number 3. Number 4, the center 2x, we're not subtracting anything. Careful, because some people want to use the square, but that's just part of the formula. We're not subtracting anything or adding anything inside of the parentheses, so that's just going to be 0. And on y, we're subtracting 1, so the opposite will be positive 1. And for the radius, we're going to take the square root of 3. So we're going to use our calculator. We put 3 and then the square root. Some calculators put first the square root and then the 3 and then equal. Okay, so in here, we just put 3 and then square root. So the radius is 1.7. If we round it to the tenths. So my center is at 0, 1, 0. And then 1 is right there. And then the radius is 1.7, meaning 1 and a little bit more than half actually, because 1.5 would be 1.5. So around there. Again, you might want to do a couple or different color and just the 2 points, and that's it. So tiny. And for this one, I will turn the paper. See, it's moving on me. There you go. More or less. Okay, number 5. The center, again, is the opposite of x, so -2. Opposite of y, also -2. And the radius is taking the square root of the 16, so that's going to be equals to 4. -2, -2, so -2 on x, -2 on y will be right there. And then the radius is 4, so 1, 2, 3, 4. 1, 2, 3, 4. Okay, so again, maybe you want to do half of it and then turn with the other side. That's it for our lesson. If you can please give us a thumbs up, subscribe around here. Here is the list for the entire unit on circles and parabolas, and here will be the next video. Now you're able to do 11.1 and have fun.